Welcome to this session of the Center for the Economics of the Internet here at the Hudson Institute. My name is Harold Furch-Scott-Roth, and I'll be your moderator today. Before we get started, just a couple of housekeeping notes. First of all, welcome to our online guests. We have a large number of online viewers for this, and if you have questions to submit, what's the hashtag Hudson Events? Call it hashtag Hudson Events and submit your questions for Professor Kuchi. Another housekeeping note on, I think it's November 18th, we'll be having Professor Ann Coughlin from the Kellogg Business School at Northwestern University. She'll be here speaking about multi-level marketing. But today, it's our great honor to have with us Professor Kiran Kuchi from the Indian Institute of Technology in Hyderabad. Professor Kuchi is one of the world's leading experts on 5G technology, and he is going to be speaking to us today about 5G in India. He is an extraordinary both technologist and entrepreneur. He teaches wireless technology at the Indian Institute of Technology. He has founded a wireless company. He goes to international standards conferences to promote new 5G technologies. And it's our great honor to have Professor Kuchi here at the Hudson Institute to teach us about 5G technology.
Thank you, Harold. It's a pleasure to be here. I met Harold a few weeks ago back in India. I had the honor to see him and show some of the stuff we're doing there. It's really a pleasure to be here and share some of my experiences of working on and developing 5G technology for India and in India. Thank you. So I lived in the United States for a good number of years before I moved back to India. I'm with the university. I'm a professor at the Indian Institute of Technology. The reason I moved back was actually to help India to develop technologies in wireless communications. I moved back in the year 2008, first to Indian Institute of Technology, Madras, that is Chennai. I spent a few years there developing a wireless communications research institute. Back then, we were interested in developing 4G technology. We did contribute quite a bit out of India to the development of a standard called 4G version of WiMAX back then. Then that kind of became an LTE 4G technology. That's when India got its first-hand experience developing wireless technologies. This is about 10 years ago. Presently, I'm with Indian Institute of Technology, Hyderabad. I'm a professor there. Ever since I moved to IIT, Hyderabad, that is about 9 years ago, I have been involved in the development of so-called 4G, advanced 4G, and now we call it 5G mobile wireless communication technologies in the university. The government of India has given substantial grants, research grants, to develop this technology and the standards and prototypes so that the nascent Indian industry can benefit from the technological advances we make in the university. Hopefully, these advancements and techniques can be commercialized by the private industry in India. This is largely the kind of work I'm involved in, technology development, development of standards, and also addressing the unique needs of Indian geography, which sometimes can be a little different, if not a whole lot of different from the Western countries. And we take these requirements to the global standards bodies like 3GPP, which is the global body responsible for defining 5G standards. I have been quite heavily involved in taking these requirements and technologies to 3GPP and standardize and make them part of global standards. and at the same time bring them to India. And we have a standards body called Telecom Standards Development Society, TSDSI. That is the equivalent of ATIS in the United States and ETSI in Europe. And TSDSI works very closely with these other standards bodies, ATIS and the other standards bodies, and ITU as well. We have been in the process of defining 5G requirements and specifications and development. So I can address more specific questions. Yeah.
Sure. Let's begin with just an overview of how 5G technology will be different from 4G technologies. I think most people today in the United States have 4G phones. Tell us a bit about how 5G will be different.
That's a very good question. 5G is not one single thing. This is what you hear from many people when they talk about 5G. So let me take a deep dive into what these many different things of 5G are. With 4G today, you have the smartphones. You can do mostly what is called mobile broadband. You can get a few Mbps, 10 Mbps, maybe up to 100 Mbps, if you're close to the cell site. 5G...
I don't get those types of speeds.
Yeah, so 5G, it has three missions. The first mission is take the download speed up to a gigabit per second anytime, anywhere. That's a formidable challenge. You don't get a gigabit per second even with a wired communication network today. Gigabit per second is a tall order, but that's the goal. And that's number one, the first mission. The second mission is what is called ultra-low latency communication. You may ask, what are the applications that you are not able to do today just because you don't have ultra-low latency? What is this ultra-low latency? Well, you make a request to communicate, in a blink of an eye, the service is delivered to you. So fraction of a second, millisecond, that's the delay that incurs a packet from source to destination to be delivered. So what does this enable? Robotic surgery and applications in industrial automation, and all kinds of different applications that we can't even think of right now. But this is quite futuristic. We really have to create the applications. There are some out there, some you have to create. But the third and most important, for me, this is the most important application, I think, for 5G, is massive machine type communication. That is, today, you have a few billion cell phone connections worldwide, maybe up to 5 billion perhaps. This is mostly for voice telephony and internet browsing. Most of the communication is from person A to person B. So that is human communication. But then if you go beyond human communication, so-called machine communication, anything that you can think of that can do a little compute, so you put a little compute, that is a small computer you put in, a very inexpensive one, and you put a sensor that can sense the environment, whatever it could be, So you make a measurement, you can sense the environment, you can do a little bit of compute, then you add communication. Then anything that you can think of, things communicate to the internet. Then this opens the door for billions and trillions of machines to connect to the internet. Trivial examples are our electricity meters. Every household has a meter. The meter can communicate to the internet, and you get the meter reading. That enables a whole lot of other things the service provider can offer. Once you have massive amounts of data, data is money. Data is priceless. That is like one example. Electricity meter, gas meter, water meter. It's countless applications. So these are the three missions 5G is after. Then you may be asking, can't 4G do this? 4G does a subset of these things very, very well. But if you want gigabit connectivity, you need massive amounts of bandwidth, and those frequencies are, they're available up higher and higher, like very high frequencies, above 6 gigahertz, like millimeter wave. United States is really spending a lot of resources on developing millimeter wave networks. That's for gigabit connectivity. But the other parts of the world, maybe they have different needs. So these are the three big things that you can do with 5G. And once you set these three missions, then you do a lot of other things, reducing the cost, providing service, and things like that. Yeah.
One of the questions I always get asked is timelines. When are we going to see 5G technologies? And so I'm going to ask you the question that I always get asked. I'm curious how you're going to tell us about timelines for 5G.
It depends on the region, right? So I think in the United States, it's practically there. At least the early versions of 5G are already here. Then the cost. What is the cost of the device? Today, a 5G phone is probably on the order of $1,000 right now. So that price has to go down. So that takes a few years, maybe 3, 4, 5 years. The massive machine-type communication networks, the early networks are available in the United States. There is a technology called Category M1, CAT M1. That's one type of machine-type communication. And the other is called narrowband IoT. I think that's also just beginning to be rolled out. I think United States is well ahead of many other countries in the 5G rollout and deployment. But there are other regions somewhat lagging behind. So I think you have all the ingredients that are required to make 5G successful are already there. It's a matter of rollout and the operator commitment and the revenues, I guess.
Right.
Yeah.
Tell us a bit more about the machine-to-machine capabilities. Where do you mentioned a little bit about healthcare. Meter reading we sort of do now as well. But there are a lot of things that just we can't even begin to imagine right now that 5G will enable, just because both the ubiquity and the speed and who knows where some of the applications will be.
Yeah, so with machine-type communication, the imagination is the limit. So you get machines to communicate, you need to make the cost of the modem as low as a few dollars. I've been working on that aspect of machine-to-machine communication. Then the battery life. With a button battery, you need to be able to last several years. Once you address these two technological challenges, I think the networks are already capable of delivering or handling the massive amount of traffic that gets generated with these small machines. And the applications are going to be huge, huge, huge. I mean, people are talking about trillions of nodes communicating to the internet. Right now, we're talking about a few billion devices connected to the internet, and we're talking about 1,000 times, 10,000 times more devices. Mm-hmm. I think it's a matter of time. Maybe we're looking at 5 years, 5 to 10 years time span. Probably that's my rough opinion. Once you start hitting these volumes, and that will change a lot of things. That will change a lot of different things. It will affect many verticals. Mm-hmm. We're talking about grid, electricity grid, that will get affected. We're talking about cities. Water, electricity, they're so fundamental to the running of the city. So the cities will start depending on these so-called Internet of Things technologies. So cities today are not equipped to handle these kind of new technologies. So I think you need to educate the cities and city managers to think in this direction and improve the efficiency of running the city, the delivery and so on and so forth. That's actually quite a challenge, That's think about it.
Right.
Yeah, we have been used to, for the past 50 years, on certain way of doing it. then you start introducing these new technologies, security, and so many things.
Right. You have, I think a lot of people, when they think of wireless technology, certain large companies come to mind, but there are also a lot of small companies, a lot of new companies, and you have one of those new companies. Tell us a bit about what your company does, some of the technologies that you're working on.
Okay. Yeah, so we do have quite a few large companies, we know of them. One of the reasons why I started developing these technologies in our small company is that, and there is a realization that India has to develop its homegrown wireless technology development and service delivery. And we have very few of them out there. So we develop the technology, we understand how to develop the technology, then we didn't have the existing companies to be able to pick up that. So then I started doing it myself. We incubated a startup in Indian Institute of Technology Incubator. It's a university technology research park. And we started developing a few wireless 5G related systems. So broadly speaking, we have two broad areas of interest. One is developing the base station for the 5G. That is basically the 5G radio communication system. From the network side, we have a prototype that we have developed in the last couple of years. That's up and running. We started to demonstrate it in various different forums. And also on the user equipment side, that is the sort of mobile device, we have an equivalent of a smartphone module communicating with the base station. This is the overall scope. But then talking about these three different missions, ultra mobile broadband and ultra low latency and Internet of Things, we have spent a lot of energy and time on developing a narrow band IoT system on chip. This chip will have a communication module and it will also have a so-called GPS type receiver in a single chip that we are developing right now together with the university. And this chip can be used for the purpose of not only machine communication, but also you can sense the location of a user, and then you can communicate the location to the network. So that's where the GPS part helps in. And this has to be very, very low cost. We're talking about just less than $2, the system on chip. Maybe ultimately the end device is just $3, $4 or $5. So our aim is to enable very low cost technology designed and developed out of India and serve the global markets, not only the Indian market. This is the purpose of this particular chip. So we go from there.
So let me see if I have this right. So you have, this is your own little company, and you're working on, you have base stations. You're working also on customer devices, and you're also developing a new chip.
Right.
And this is all, it's all very ambitious. There's a lot going on. Then this is even to develop one of these would be an ambitious project. But you're doing three different things all in your company. Is that right?
Yeah. Harold, you have to understand that in India we have a lot of people. We're talking about not just a few people like here.
No,
we have a lot of people, and we have a lot of young people.
Right.
And they're willing to work hard, provided there is an opportunity. And I think we can do it. Just a matter of time. Some little bit of luck, and
You're far too modest, Professor Kuchi. I'm simply trying to emphasize the entrepreneurial nature of pulling this all together. It's
So,
quite simple.
of course, you're right. Usually, one company, one simple idea. That's the philosophy.
Yeah.
We have, instead of one, we have two or three. But we'll see, and we'll get there. Yeah.
Tell us a bit more about wireless services, wireless technology in India. How is India different, or how is India the same from other countries such as the United States?
Yeah, this is where we spend a lot of time and energy on this similarities and differences. On the urban part, the Indian service providers have very similar challenges compared to the Western counterparts, but there is a key difference. The amount of fiber that is available inside the buildings on the street is much less compared to the Western world. That means the amount of Wi-Fi that you can develop and deploy is very little in India. So mobile broadband is the only broadband that we can think of. Wireline is practically non-existent. I mean, it's there, a few million. For us, few million is just a few. We're talking about hundreds of millions of connections. We're talking about 500 million connections out there. So India is different because we did not have copper penetration and subsequently fiber penetration. There are a few companies bringing fiber to the home, but that's very little. So therefore, in 2G and 3G, when Indian service providers offered wireless services, they had to rely a whole lot on microwave backhaul. That is little dumbbells that connect from one cell site to another. That's also wireless. Now, with 4G, that's not good enough. You need fiber to every cell site. So a few operators have now, I think they have deployed enough fiber maybe to be able to carry 4G traffic and provide the so-called tens of megabits per second kind of service. Right now, I think India has probably close to maybe 500,000 cell sites, 4G cell sites. I have to check the exact numbers, but something on that order. Mm-hmm. And not all of them are fiber connected as of now. Some of them do rely on microwave backhaul. So the lack of fiber and the lack of Wi-Fi, there's no Wi-Fi offload. No, there's no significant Wi-Fi offload. So this is the biggest difference between our urban wireless deployment and the, let's say, United States urban deployment.
In the United States, it's roughly 85% of wireless traffic is offloaded onto Wi-Fi. So that's an enormous difference, yeah.
And there is another difference. That's something you work on, spectrum.
Yeah.
Today, all the wireless traffic is delivered through 4G LTE network, and the cell sites are max capacity, and the amount of bandwidth available in each cell site is roughly 120 megahertz TDD, 2.3 gigahertz band. Roughly speaking, I mean, different operators have different spectral resources, but by and large, this 20 megahertz TD, what we call TD-LTE, is what is the workhorse for the mobile broadband. Mm-hmm. And imagine 20 megahertz nationwide network. You're serving about 300 million maybe customers, and unlimited data for what, $10 to $10 per month service or less. So the burden on the network is huge. No Wi-Fi offload or little Wi-Fi offload, little spectrum, and higher frequency, relatively higher frequency. The challenges are enormous for urban. When you go to the rural side, that's a whole different ballgame. The government of India itself has taken the lead, and they are taking fiber to 250,000 villages. They're not really villages, they're village heads. Each village is a cluster of 4 or 5 small villages. Nationwide fiber rollout is ongoing to cover the whole of rural India. And at the fiber drop, you have to put a cell site that covers about 4 or 5 kilometers of radius. That is the biggest challenge for the government. And we are working on a specific version of 5G that brings the cell radius, that expands the cell radius from 200 meters, 300 meters to about 4-5 kilometers using this so-called high frequencies, 2.3 gigahertz. That's a very unique Indian challenge. So you can already see I laid down a few different things that makes the Indian market not so similar to the United States.
Yes, those are very different situations from the United States.
And the challenge is when the standards are developed, they are driven by who? The first two operators who are going to pay the bill, and the technology is primarily tailored for those operators that we are going to deploy initially. Mm-hmm. And then this technology gets commoditized and sort of goes down to India and Africa and other places. But that becomes very challenging for India. That's why we want to come to the standards while the standards are developed and project these requirements. And it's 500 million users out there.
More than half. I think it's 1.2 billion wireless connections in India.
Yeah, and 500 million smartphone market. Right. I'm not counting the.
You're not counting. Oh, I see. You're not counting the.
I'm not counting the voice.
Yeah, got it.
So 500 million smartphone market out there.
Right.
Yeah.
Wow.
Yeah, that's big numbers.
Tell us a bit about the standard setting bodies and your participation in them, and how much of your time this is taking up going to the standards bodies.
Oh, I've started participating in these standards bodies about 10 years ago. It's very unusual for a university professor to be there. In the beginning, they were very surprised, why are you here? Mm-hmm. Because it's driven by very, very, very large companies. And they have R&D teams of anywhere from 50 people to 1,000 people. So what happened was that India did not have a representation in 5G standards. So we had to first fill that gap. The government of India has given the grants to the university, not only to do research and also to go to the standards bodies and project the requirements. Mm-hmm. Specifically for 5G, I started traveling to these so-called 3GPP meetings about 3 years ago from day one of 5G standardization. To begin with, I was the only person from India. I have made like maybe 32 trips in 3 years, these international trips, and go there, first start telling them who I am, what I do, and so, but 3 years down the road, we have about 10 people going from India, from my team, or the kind of the team from India, you can say so. They know the team from India. They kind of value the opinions we bring in there. We are also successful in a way that we introduced a piece of technology in 5G that expands the cell radius by about 50% to 100%, especially for the rural utilization. That's a contribution that came out of our group. People kind of acknowledge that. And we are actually taking these technologies back to the products that are deployed in India. This is the next goal. So, and we said, I laid the foundation for this standards contribution. Now, the government has recognized the need, and the program is being expanded. And hopefully, for the next generation 5G plus, we will start to contribute much more. But it's just a beginning.
Wow. And you're working on chipsets that you said you want to get the price down to about $1 to $2. Is that the?
Yeah. That's the Internet of Things chipsets. The chipset is about a couple of dollars, and then the module per se, maybe just you had to add another $1 or $2 to the module. So you can just plug it in wherever you need. That's the kind of price points we are looking at.
And your company, tell us a bit about that. You have a lot of graduate students working for you, is that right?
Yeah, so the way it is structured is that the first set of people that I recruited, the people that I was working with, the graduate students who worked with me, and they kind of jumped the ship and started working for our company. And sometimes they do their studies part-time, things like that. That's the critical mass I got, the first set of people. People who knew me for a few years, and they were all trained by me. Now we're able to recruit people from around the metroplex of Hyderabad and other parts of India. Slowly we're increasing the strength. So that's how universities are a great place to attract young talent. Difficult to start a company outside in the city and recruit people. University is a great place.
That's great. And what do you see as sort of, are there similar companies to yours around India as well, developing India-grown technologies in the wireless 5G space?
Very few. There have been a few startups, not necessarily in the 5G space, but generally in wireless space. Very difficult to operate a company out of India. Very challenging. Very challenging.
How so? Why is it challenging more so there than anywhere else?
First of all, there is no success story. People really like success stories. If you're successful, if there are one or two success stories, then people believe in them. So we don't have such success stories in the wireless space. That's one. The second one is market access. A company incubated out of India does not necessarily have a preferential market access to the Indian market. It's not there. It's anybody's opportunity out there with respect to procurement of equipment and so on and so forth. So and it's very expensive to develop these technologies. These are very cutting edge technologies, very expensive. There is no venture money in India for this kind of chip development and things like that. It's very early days. I mean, there may be little venture money, but very early days. But I believe that, I think going forward, developing these technologies out of India, designed in India, not necessarily made for India, but you can use it in India, but actually serve the rest of the world. This could be a pretty good and compelling use case.
I think that makes it all the more remarkable that you've been able to develop this company the way you have without the, so it really is, you're breaking new frontiers and doing this. So it's really good. I'm going to open things up for questions, and then I could just go on all day, but I'm sure people here have questions for Professor Kuchi. Questions from the audience here? Yes. Please, we have microphones. Please identify yourself and
thank you very much for this very promising, futuristic, entrepreneurial spirit which you bring in India. My name is Ram Janakiram. I work in the area of data services in rural areas, where I think internet in rural areas will play a major role. Looking forward, how do you see the landscape changing to bring internet-based services on the content side of things? You spoke on the hardware and all, which is extremely important on the infrastructure side. Now, on the institutional side, how do you see the content, meaning data, information, knowledge services, which can improve the decision-making of members of a rural household to improve their productivity in agriculture, say across the value chain, which a lot of inefficiencies are there. And I see a lot of potential for developing applications in that area, which will give immediate benefit to many rural population. Thank you.
Thank you, sir. Well, this is one of the bigger issues that we grapple with in India, because 70% of India's population is still in rural areas. And the urban cities are getting crowded, and it's if you can develop high-speed internet access and Internet of Things services reliably for rural population, I think it'll make wonders. Addressing the specific question, we have large parts of rural areas are agricultural based. There are fisheries and lots of different agro products. There are a lot of experimental studies and networks being developed, mostly from a content point of view in India, and how best you can bring in efficiencies especially in the agricultural segment through wireless technologies. These studies have been going on for almost a decade now, since I have seen. It will probably take a little more time before you see these information-centric products hitting the agricultural market. There is what is called precision agriculture. That's going to be fairly big in India, and the government has a lot of emphasis on bringing technologies to improve productivities in agriculture. But India is slightly different from other countries because the land holdings are very small. You have a farmer holding anywhere from half an acre to 10 acres. So that's very different from the other places. And given those different local constraints and considerations, how do you bring in productivity using this massive machine type communication as well as the information centric? This is definitely a topic very important for Indian market. There are people really working on this, using drones and wireless communications on the agri side. I'm just only talking about one particular use case here, and there are a lot of other rural centers. Yeah. So the government wants to really bring in efficiencies in the agro side. Yeah. So we can discuss more offline. Yeah. Thank you. Yeah.
Just to follow up, in the U.S., the precision agriculture is also very big, and it's tied into satellite GPS services. And as I recall, one of the things you've been working on is precisely bringing Indian navigation system into 3GPP. Is that right?
Yeah. That's more of a serendipity because the Indian Space Research Organization has developed this constellation. It has been in use. It's an alternative to GPS. Just only a week ago, somebody called me up. I said, "You're going to 3GPP. Can you please handle this?" This is how it started, just about 10 days ago. So I took this proposal to 3GPP. Today, we have GPS, the American constellation, and Galileo, the European constellation, Baidu, the Chinese, and GLONASS, the Russian. The 3GPP standards support all these constellations, and in the phone, you can use any one or all of these constellations to do positioning, that is to get the lat long, the location of the device. So we introduced the Indian constellation as part of 3GPP specifications. It is approved. It took some effort, to get this thing done in one meeting in 3GPP, but we managed to do it. And now, I think a year or two from now, probably most of the devices sold in India will end up supporting this NAVIC. NAVIC stands for navigation. This yet another constellation. So yeah.
Great. Next question. Gentleman here.
My name is Troy Lin. I work in international development. I'm curious about your opinion for 5G, for IoT and rural sensors in international development. 5G has a competitor, LoRa, right? And it's a very efficient protocol. When you think about sensors in ag and water quality, water content, water levels, the amount of data that needs to be transferred is actually very little sent. And 5G seems like to too powerful of a technology, really, for what you really need for sensors in a rural setting in developing countries. I mean, and for now, like use of LoRa devices and LoRa sensors it's expanding pretty rapidly. So do you think that LoRa is a really competitor for 5G, or in the IoT space, particularly in non-dense and rural areas?
Yeah, so I think very early on I said 5G is not one single thing. It has many forms and shapes. The alternative to LoRa you're talking about, devices sending a few bits every now and then. They're sleeping most of the time. You just send a few bits, every hour or half an hour or every other day. LoRa addresses this segment. But in 5G, there are two protocols or systems, you may call it. One of them is narrowband IoT. That's the flagship 5G massive machine type communication technology. Luckily, you don't need to put a new network out there to enable this. The existing LTE base stations, the towers out there, they remain intact, and you vacate 200 kilohertz from your LTE spectrum, and you do a software upgrade of the cell site, and you can start transmitting these so-called narrowband IoT signals without changing the hardware. And the devices, of course, need to have a new chipset, which I was talking about a few moments ago. And this device will see a narrowband IoT transmission from a device perspective. From a network and infrastructure perspective, you don't really add a whole lot of cost. It's just a software upgrade. So, and this is beginning to happen. First, it was proliferated in China. India is beginning to deploy it starting January. And the United States started doing it like 6 months or a year ago. And Europe is already doing this narrowband IoT transmission. So LoRa uses unlicensed frequencies, whereas narrowband IoT uses the licensed spectrum, but a little of it from the existing 4G. But we still call it 5G because it's not part of 4G family. It was not launched like a few years ago. So it's kind of in between solution, but 5G offers this as one of the machine type communication. Whether it's going to be LoRa or narrowband IoT, I will leave up to speculation.
Yeah, I'd say 5G, unlike prior generations of wireless technology, has a bit of definitional imperialism of everything becomes 5G. And it is not as precisely defined as prior generations were. Gentleman here.
Good morning. I'm Clayton Leobrotten with the Chatterjee Group out of New York City and Kolkata, and thank you so much for this session. You've talked a little bit about the backhaul, so the fiber that's required, and Wi-Fi offload. Can you talk a little bit about 5G propagation in urban versus rural settings? In other words, the tower density, or will 5G penetrate, fortified structures with, glass, steel, cement, or is there a greater need for edge networking in those type of situations?
So I believe, just to rephrase your question, you're talking about specifically the high millimeter wave frequencies based 5G. Will it propagate the walls? That's how I should phrase the question?
Yes, so
okay.
You've got industrial IoT in a manufacturing plant with connected machines or
right.
environmental sensors. Is 5G from towers going to propagate into those types of buildings, or will there be a requirement for repeaters and edge networking?
Okay, so that's one of the confusion always arises out of 5G. Up till now, there is only one single use case up till 4G. Now 5G is not one thing. It has a network based on millimeter wave frequencies, around 20 to 30 gigahertz range. Those frequencies have a hard time penetrating inside the buildings. So you'll probably have to put a repeater up at outside the window and then maybe redirect the signal. But is it meant for industrial IoT? Well, I mean, you can't put a tower outside and expect to get Internet of Things services at signals, with signals transmitted at 28 gigahertz or on that range. That's quite difficult. So what people are doing is that put up a massive amount of infrastructure out there, like every other light, street light kind of spacing. You put the millimeter wave transmission node, and then people driving around or people inside buildings try to connect. If you're not successful, you fall back onto like 5G, like 4G service. So it's a switching between high speed and low speed. But then for Internet of Things services, it has got to be a transmission node inside the building. If it has got to be, with these high frequencies, but it's quite unlikely. You don't do millimeter wave inside the buildings for IoT. For IoT, you rely on what I just described as narrowband IoT. Typically, the transmission is around 800 megahertz, and that can penetrate 2-3 walls. And the system is designed to penetrate a couple of walls, even deep underground. You can have a meter deep underground, and you can still make a connection using the so-called narrowband IoT. Yeah. So.
This gentleman here.
Hi, fascinating discussion. I'm Jay Chahan, Freedom Technologies. I do wireless policy consulting for commercial and government clients, so I'm going to ask you a spectrum-related question. I'm fascinated that India only uses 2.3 gigahertz for the workhorse. A lot of our devices here in the United States have low, mid, high band ranges now with the 24 and 28 gigahertz 5G networks coming on board. So what are the timelines for India to deploy 5G, and then what particular frequency bands will be made available by the regulator to make that happen?
Yeah. So let me just make it a bit clear on what I just said. 2.3 gigahertz band 40, 20 megahertz band is the workhorse. But we do have quite a bit of other bands. For example, one particular operator has up to 70 megahertz or 100 megahertz bandwidth. But then they have 2G, 3G services in those bands. So when I say notionally the workhorse is 20 megahertz, that's the largest chunk available in sub 6, below 6 gigahertz. That's what I mean to say. But there are other bands available to different operators. Now, what is India going to do next? I think that it is more or less agreed. There is consensus that 3.5 gigahertz. I mean to say that's kind of band. India is probably going to auction about 200 megahertz in that, something in that range, in that band. So there are 3 private operators and there is 1 state operator. Thankfully, we have now fewer because it used to be a crowded space. We had a lot more operators. Now it's 3 plus 1. So the operators can bid up to 60 megahertz, 80 megahertz in that range, and the pricing has been already set, the base price, by the Indian regulator. The auctions are probably end of the year, early next year. That's the word on the street.
That's. Do they have to do proceedings and announcements before? That's very quick to have the auction.
You mean the 5G auction?
Yeah.
This is sub 6 only. There is no millimeter wave auction on the horizon. I think what I hear from the press is that the auction is scheduled around the end of the year and early next year. Now there are a lot of different opinions on that. But I think one thing that is clear is that the operators do need the spectrum. There's no doubt about it. So there is a need for spectrum. That part is very clear.
Do you think that's enough spectrum in 3.5 gigahertz?
Oh yeah.
For 5G to get all the benefits for 5G?
Yeah, if India could do with 20 megahertz, they could do nationwide broadband services. 20 megahertz, says per operator. There's no reason why you could do with 2 or 3 times as much in a band fairly close to that band.
Are there plans for millimeter wave?
No. That's quite complex, and we're nowhere close to.
Interesting. Yeah. This gentleman here.
John Pilitich, State Department, and fascinating discussion. It's a pity I missed a bit earlier on, but listened a little bit about the challenges of sort of local companies engaging in the market, and also the sort of last mile challenges, the getting connectivity out to the villages or villagettes, as you mentioned. And I'm just curious, I know that there's like certain US companies like American Tower out there with a significant presence. Is the engagement from the side of the government partially because there's not, let's say, a business solution seen there, or it's not profitable? Could you maybe talk a little bit about that?
You mean the rural?
Yeah.
Yeah, I mean, well, there is a lot more rural connectivity now than a few years ago, but still not enough, you know. In India, the connectivity on the national highways, the road, is usually pretty good. The connectivity along the rail track is reasonably good, if not the best. And a lot of people actually do live along the national highways or the rail track. But then the issue is with, the deeper inside, so-called remote places where there is no rail track or a national highway. These are the hot places, and India is a fairly large country. So the program that I talked about is actually aimed for those villages, about 250,000 villages, are so-called bigger villages, spaced 5-10 kilometers apart. So the government is bringing fiber to the so-called villages, head of the village. That program is ongoing. Probably in a few years, we'll have fiber to practically these 250,000 villages. That doesn't solve the problem yet. You just bring the fiber there, but then you have to put a wireless network. And that still is a harder problem. Who is going to put up the network, whether it is profitable? The revenues from the rural areas is always not as high. And today the wireless infrastructure is based on licensed spectrum. And will the operator provide 100% coverage in the rural areas? I'm pretty sure the United States has a similar challenge there.
Yeah, we have similar challenges.
Yeah, but just that the number of people living in India is a lot more in those areas than compared to here. It's tough. That's a challenge. So you need to find the technological solutions as well as it's related to policy and regulation.
Well, please join me in thanking Professor Kuchi.
Thank you.